Welcome to this Axiomatics webinar. Today's topic will be around building an effective API security framework using attribute-based access control. I'm happy to say that today for this webinar we will be joined by Alex Gudanis of Advansive, one of our technical partners over in California. First of all, for those of you not familiar with webinars, here are some guidelines that you might want to know. You are essentially muted, so do not worry about making any noise. It won't be picked up. The webinar is being recorded, so you will be able to watch it later and share it with colleagues and others. The slides we're using right now will be made available for download from the Axiomatics website at www.axiomatics.com. And we will be saving about 10 minutes at the end for a Q&A session. You can use the GoToWebinar panel on the right-hand side to type in your questions. Today's speakers are Alex Gudanis, who is a Principal Solutions Architect with Advansive Technology Solution, and myself, David Broussard. I am responsible for customer relations at Axiomatics. Alex and I have been working together on an integrated solution using our product for a customer in the US, and that will be the use case for today's webinar. So first of all, we will be discussing an API security framework, how to provide best-in-class security for your APIs and web services using the Axiomatics Policy Server. Then Alex will take us into a live demo of the capabilities, and then we'll save some time, like I said, for a Q&A session. But before, let's give a bit of background on Axiomatics, and let's give a bit of an introduction on attribute-based access control. First of all, Axiomatics is the leading provider of ABAC solutions and externalized authorization. We deliver fine-grained externalized authorization to large organizations around the world. These organizations use our flagship products, both the Axiomatics Policy Server for APIs and business logic, as well as the Axiomatics Data Access Filter for database protection for hundreds of apps, thousands of applications, APIs, web services, databases. In addition, we cater to millions of users in some of our customer use cases where they expose the APIs to consumers, for instance. Last but not least, I'd like to mention that we were recently recognized as a product and innovation leader by Cole, the leading identity and access management analyst firm in Europe. And that is in, that is part of the report that Cole recently published on dynamic authorization management. So let's have a look at ABAC and the ABAC timeline. If we go back 5 years or so, the U.S. Federal CIO Council, or FICAM, published a roadmap and an implementation plan for ABAC, or that advocates ABAC to establish fine-grained authorization and good best practices access control. 2 years later, in 2011, a new version of FICAM came up, FICAM version 2.0, and in that particular roadmap, ABAC is recommended as the access control model for promoting information sharing between diverse and disparate organizations. This is particularly important when you're dealing with large organizations or governmental organizations that have to deal with multiple different agencies in different locations, potentially different jurisdictions across many different boundaries. Moving on to 2012, and you have the National Strategy for Information Sharing and Safeguarding. That strategy included a priority objective to implement FICAM, the FICAM roadmap. So in 2012, we have the first executive decision, or the first implementation decision with respect to ABAC. Moving on to earlier this year, NIST published an excellent report on the topic of attribute-based access control. That report is called 800-162. I highly recommend that you all read it if you have not done so already. It goes into the basic definitions of ABAC as well as advanced topics on how to best deploy your ABAC strategy, who to bring together within the enterprise, which roles you need to have, how to establish policy requirements gathering, so on and so forth. It's a very, very good report. And the last 2 dates on this timeline relate, first of all, to Gartner predicting that by 2020, 70% of all businesses will be using ABAC, or attribute-based access control, as the dominant mechanism to protect critical assets, up from an estimated 5% today. And of course, our question to you is, are you part of those 70%? Are you ready? And then, as I mentioned on the previous slide, Coopering and Cole published a leadership compass on dynamic authorization. You can download that report for free from the axiomatics.com website. So I used ABAC and I used attribute-based access control in these first few slides more than I can remember. But what is it exactly? First and foremost, it is a mode of externalized authorization. Externalized authorization in itself is not a new concept. Many different programming frameworks, many commercial applications do achieve externalized authorization by storing configuration in a table in a database or other means. However, externalized authorization was never standardized. It was never uh, centralized in one single place, which meant that you would reinvent the wheel with each and every application. ABAC tries to propose a model based on attributes and based on policies and rules and based on a standard called XACML to achieve your centralized externalized authorization in one way that you can reuse across your many applications. And of course, some of the benefits include the ability to consolidate your authorization logic in one location, and therefore you save money. One other benefit includes the ability to provide better security, simply, and that you avoid fines through that way. One huge benefit we've seen with our customers is, of course, the ability to implement very complex compliance and regulations rules, which before with, say, access control lists or role-based access control were not easily achievable. One great example of a very complex compliance package, if you like, is the export control regulation as set by the Department of Commerce. These export control regulations are a great example where ABAC fits perfectly. Now, like I said, the Extensible Access Control Markup Language, or XACML, is an implementation of an ABAC system in a standardized way. XACML is designed and developed by the OASIS Technical Committee of the same name, and there are many different companies that take part, vendors such as Axiomatics, but also end-user organizations such as Boeing and Bank of America. Finally, one last point to mention about ABAC, XACML, and externalized authorization is that the way you build your policies is in a way where the policies use attributes to describe specific access control rules. And that's the reason why we call it ABAC in the first place. But also the interesting thing is that the technical authorization policies match very closely the plain old English authorization policies. So where in the past, if you had RBAC or access control lists, there was a huge gap between the original English intent and the actual implemented artifacts. Today, with policy-based access control, with attribute-based access control, that gap is next to none, which means it's easier to understand these authorization policies, it's easier to audit. Later in the webinar, Alex will be showing us some examples based on HL7, and these are a great illustration of how XACML can implement very quickly HL7 regulations and still retain the meaning so that anyone can read them and understand them. Another way to summarize what ABAC is to think that historically authorization frameworks have been about who you are. But in fact, it's not just about who you are, but it's also about what, when, where, why, and how. The 5 W's and the H rule. And those different categories, who, what, when, where, why, how, are all described with attributes. So who is the identity of the user. The what is what the person wants to access. When, where, why, and how belong more so to the contextual information or the environment. And more importantly, you can finally express relationships in a very straightforward way, in a very easy way. Now you can actually build access control that depends on the relationship between the user and the resource. HL7, again, that Alex will show us in a minute, is a great example where we exploit the relationship of the physician with the patient that they're trying to treat. ABAC also enables something that I like very much called the any-depth architecture. The notion that where in the past each and every application would have their own authorization model that would be technology specific, with ABAC and with externalized authorization, you can achieve technology neutral, any-depth authorization. It means that you have your authorization service centrally managed, and you can deploy different plugins, you can deploy different enforcement points in the layer that matters most to you. And by having those enforcement points call out to the centralized authorization service, you guarantee that you enforce the exact same authorization logic no matter which layer you sit in. And if you look at the picture here, from top to bottom, the top layer is the presentation tier, where you might want to use fine-grained authorization for user experience to render the relevant UIs, enable the right buttons, show the right menus. Moving one level down, you reach the access management layer. For instance, here, the Web SSO layer with SiteMinder, which is a product Axiomatics integrates with, and where you can do coarse to medium-grain access control using the URLs that are being protected. Moving on one layer, you reach the web app and web service tier. That's the topic of today's webinar. We'll be looking at how you can protect APIs and web services by simply deploying a policy that will protect the web service endpoints, and by using an XML gateway, in this case, the layer 7 XML gateway. Moving on one layer, you reach the business tier where you have your applications written in many different languages. It could be .NET, Java, Ruby, Python. It does not matter because externalized authorization is technology neutral. And there, Alex has a really nice trick up his sleeve that relates to integrating with Spring Security. Finally, we can move on to the data tier where we can apply fine-grained authorization there by using, for instance, the data access filter by Axiomatics. So if we walk back up this stack, at the bottom, you have the data access filter. Moving up, you have the Spring Security integration that Alex will mention, and moving up still in this webinar, the integration with the Layer 7 API gateway. And on that note, I'll go ahead and hand it over to Alex, who will introduce himself and introduce Advansive. Thanks for listening, and Alex, over to you.
My name is Alex Gudanis. I'm a Principal Solutions Architect with Advanced Technology Solutions. We're Axiomatics partner, and I've been working on a few interesting projects together. Just really quick about Advansive, who we are. We're really a consulting and a SI firm. Our main competency is identity and access management. That's pretty much most of what we do. We've been around since May 2009, headquartered in Southern California in Pasadena, and have a major presence in Bangalore, India as well. And really serving clients in most of the key verticals: finance, healthcare, telecom. So with that, I'm going to go to the case study that we're going to be talking about today, which is based on a project that we did for one of our clients. That was a project that we did jointly with Axiomatics, and it was really around the healthcare clinical decision support system, which client really wanted to expose as a service to their customers, right? And the system would to provide data access APIs to different clients, which include healthcare information exchange networks, mobile applications, or any other type of clients that potentially need to use the data from the system. Their main goal was really to build a security framework that provides the controls that are needed to ensure their security and compliance requirements. And one of those key requirements, as David was talking about the authorization in depth, was to provide a flexible attribute-based authorization framework that they can really use across multiple layers of their application architecture. So quick look at the solution architecture overview. Obviously, as you can see from the diagram, the scope of that project was much bigger than what we're going to be talking about today. It really, we had to deal with a lot of different aspects of security, SQL injections, API threat management, database security. I think specifically the components that we will be focusing on today, I highlighted them in red, are Layer 7, WebLogic, and the Axiomatics Policy Server. Obviously, the Layer 7 is the API gateway that exposed and protected the APIs out to the clients. WebLogic is the application server that runs the backend logic for the APIs, and the Axiomatics Policy Server was responsible for enforcing the authorization security policies. So let's talk a little bit about the authorization framework. So we really built the framework around the HL7 security and privacy use cases. For those who are not familiar with HL7, it's a standards body that defines different protocols and standards for healthcare type information exchanges, and part of their standards really define security use cases as well that most healthcare systems should implement. And those use cases really cover some main areas of the access control, right? And those areas are access control based on category of action, access control based on category of object, based on category of structural roles, functional roles, and multiple role values. And we will go through them on the next slides to explain what they are. And I also want to say that even though HL7 defines those areas of access control, I think those categories are pretty common for other systems, not just the healthcare systems, as you'll see in the next few slides. So when we talk about access control based on category of action, what it really means is that we want to control access to an object based on the type of action that is to be performed on it. A couple examples. For example, a primary physician can create patient's progress note, right? Create is the action, so we want to control access based on that. Or a physician can update patient's progress note that he or she wrote themselves, right? So here we highlight the actions that can be performed on certain objects. Access control based on category of object really deals on the type of object that we want to protect and control access to. Again, a couple examples. A primary physician can have a full access to patient's assessment, right? Assessment is the object, and that's the object we want to control access to. Or a primary physician cannot access patient's payment history without additional authorization. So again, the requirements here are around controlling access to the type of objects. Access control based on category of structural role really talks about the controlling access to the object based on the roles that are assigned to users who are requesting access to those objects. And typically, the structural role reflects a human or organizational category, who that person really is, right? For example, a physician, any person who is a physician can read medical records of all patients. Or somebody who is an admission clerk does not have access to patients' medical records without additional authorization. So here we're really talking about the type of user who is requesting access to certain information. Access control based on category of functional role. So functional role really bound to the performance of actions that are carried out by the user. And the period of that functional performance can be limited to some sort of a time interval. And a good example of that would be, for example, you have an alternate privileged healthcare professional who can read or update patient's medical record, including sensitive information, while that patient's primary physician is on vacation. So what that means is we have somebody who is a privileged healthcare professional who can assume a role of the physician for some period of time. And that's what we mean here by functional role. It's a function that the user is playing at the time of performing the request. And access control based on multiple role values. This is really controlling access based on the user being assigned more than one role attribute value, right? So, for example, a requirement could be a staff physician, meaning that the user must be a physician and also a hospital staff member to be able to update patient's care plan. And before I move,
and what's interesting here, Alex, as well, is that, sorry for jumping in, what's also interesting with multiple role values is that you can also extremely easily implement segregation of duty checks if you want to through the use of XACML policies. So in addition to those multiple roles, you can also make sure that you don't have any toxic combinations.
That's right. Thanks, Dave. Okay. So what are the really process of defining the authorization policy, right? Where do we start and how do we go about it? And it usually involves 3 steps, right? So typically we want to analyze the functional use case, right? What are the requirements from the application? analyze the use case, and really develop a natural language policy. Just express the authorization decision in plain English, right? So we can understand what exactly we need to enforce. And then translate those natural language policies into more of executable policies and attributes using some sort of policy authoring tools, right? So we can create, I'll say, XACML policy. So let's take a look at the example. So we'll look at one specific use case, and we'll essentially walk through the complete cycle. We'll look at the use case. We'll look what the natural language policy looks like. And then we'll look at XACML policy, and then we can go through the actual API implementation based on that use case. So the example use case, we have essentially three actors. We have Sam Jones, who is the patient at the hospital. We have Dr. Bob, who is the physician and also a primary physician for Sam. And we also have a Dr. Dan, who also works at the hospital, also a physician, and sometimes treats Sam, but he's not his primary physician. And the basic scenario for the use case would be that we'll take Dr. Bob examines Sam Jones as part of the episode of care. Doctor opens patient's medical record, reads his medical history, and then he notices a transcription error in the progress note. And doctor can correct the error and update the progress note. Doctor can create a new progress note and enter a new observation for the new visit, and then append the result of a recent blood test of the progress note. Right, so this is the kind of happy path scenario, right? And the post-condition of the use case is that the progress note regarding the past visit of Mr. Jones is being updated, and the new progress note has been created and appended to. And this is possible because Dr. Bob essentially is the primary care physician for Sam Jones, and he can essentially create and update the progress notes for that patient. As an alternative scenario, Dr. Bob examines Mr. Jones, and then he notices that Dr. Dan created a progress note, and there was an error in that progress note. And Dr. Bob attempts to correct that error, but it is denied this privilege by the system. And essentially, the requirement here is that only the physician who created the progress note can actually make changes to it. And in this case, the post-condition would be that the progress note from Dr. Dan would remain unchanged because Dr. Bob was denied that privilege. So if we look at these use cases, we can put together a couple of natural language policies, right? Just like I said previously. Policy number one would be a primary physician can create and update patient's progress note. And then the policy number two is that a physician can update patient's progress note if he or she is the author of that progress note. And also, when I write the natural language policies, I like to highlight certain constructs of that policy to help me identify the resources, the objects, the actions, and the additional attributes. So, for example, I bolded the progress note because that's going to be the resource that we're going to be protecting access to. And then create and update our actions, so I underline those. And then the additional attributes that are going to be required to enforce that policy, I put in italic. So, for example, we know that we need to identify a primary physician or physician or the author of the object. And by the way, David, do you have any comments on this? I know that you like to color code.
Correct. So I do pretty much the same as you do, and I like to think in terms of, number one, to carry 4 highlighters with me, 4 different colors for subject, resource, action, and environment, which are the 4 standard categories in XACML. And the other point is that those 4 categories, they map directly into grammatical constructs that we're familiar with. So the subject, of course, is the subject of a sentence. The resource would be the object of the sentence. The action is the verb. And then the environment is pretty much the rest, the contextual information. It could be time of the day. So it's really easy to relate a plain old English policy to an ABAC or XACML policy. And the second point, or the last point I want to make, Alex, is that here we've got two policies as examples, but as a matter of fact, you can very much easily add yet another policy, and another, and finally decide how they all combine together. Back to you, Alex.
Correct. Thanks, Dave. So now that we have the natural language policy defined, we can actually go ahead and create an executable policy. And I know some people like to code XACML in its native format, the XML, but I think there's actually a better way of doing that using Alpha, which is the Eclipse plugin developed by Axiomatics, and it uses more of a Java-like, English-like constructs to define the policies. So we normally prefer to use that instead. And we would start defining our Alpha policy by really defining the attributes, right? So if we identify those attributes in our natural language policy, we know what they are, right? We're going to need the role of the user. We need to be able to identify the physician. We're going to need to know the requester ID, right? Because we need to map the request to the user who's requesting access to an object, so we can know who that person is. Obviously, we need to know the action. So these are creates or updates. We'll need an attribute for the author of the object to enforce the policy, and another attribute is called primary physician, because that was also part of the policy. So we need to be able to determine that as an attribute of the policy definition. And once we have our attributes defined, we can actually write the alpha policy. And using our example, this is what the alpha policy would look like. Or it's not the complete policy, but it's pretty much 80–90% of it. So essentially, we'll create a policy called progress nodes. The target of that policy is going to be object of type progress node, and there's going to be a couple of rules. One rule for creating a node, and a user who has a role of physician and performing an action of create, and meets the additional condition of being the primary physician can create a node. For update, a similar rule that requires user to be in the role of physician. It needs to be able to perform the action of update. And the additional condition there is that the requester must also be the author of the role. And that's what that policy really looks like. Once we have this alpha policy defined, the Eclipse plugin will actually generate the XACML XML definition that we can then upload to the the Axiomatics PDPs. Now let's take a quick look at the API specification that we're going to be using for this demo. Obviously, the APIs can be implemented in any different formats, right? It could be SOAP web services, REST web services. We can use JSON, we can use XML as a payload for the API. So for this particular example, we'll just use a REST style API, and we'll use an XML payload to pass the data. And we'll essentially have two URLs that we're going to be just issuing HTTP posts to. One is for creating the progress node, one for updating the progress node. And we're going to be passing the sample XML as you see on the screen. It is going to have some attributes about the progress node, such as the patient ID, physician ID, the actual node, and some additional attributes. And our API is going to essentially take that payload and either create or update the data in a database, in a Oracle database. As far as data sources, so we have a couple data sources as part of this demo. One is the actual Active Directory that has the hospital staff accounts, and Active Directory also holds their role information as one of the user attributes. And the rest of the data is really in the Oracle database, and there is a few tables that are of interest for us for this particular demo. Table actors that have the hospital staff information. It's information about the doctors. Patient table has the patient information. Patient medical history contains medical records. And then patient progress note contains data about the patient progress notes. And we will look at those tables as we go through the demo. the actual implementation on the API gateway, right? So first of all, we need to expose the API to our clients, right? And as we said, in this particular case study, this particular demo, we will use a layer 7 API gateway. What it really allows us to do, layer 7 allows us to define a public API, right, that we can expose to external clients. It performs a number of different things on the API. It can do request validation, it can do schema validation, you can implement API threat protection, and we can also authorize the request of the APIs through the externalized authorization framework, such as Axiomatics. Now, layer 7 itself does not have a built-in XACML PEP. At least it didn't have it as a version 8.0. But we can still implement that functionality as what they call a reusable policy fragment, and using out-of-the-box HTTP request routing capability. And I will show you how that's configured in layer 7. And we will essentially going to have to build the exact.
Alex, let me.
Yeah. Go ahead.
Sorry, let me just jump in for a second. So they do now have a built-in enforcement point, but the fact that they do doesn't really matter because, as you explained, with their own native capabilities, they can create any XML message to any third-party web server, including our policy decision point.
That's correct. Right? We can, and that's what I'm talking about. The implementing the HTTP request routing, that we'll have to build the XACML request and send it off to the Axiomatics PDP. What I meant by no XACML PDP is a pre-built component. Is, in layer 7 you can drag and drop certain pre-built components. So there's not a specific one for XACML, but that can be really easily built using the policy fragments and HTTP request capability. And what we're going to have to do is to really build the XACML request using the request attributes from the API call and the attributes from the actual XML payload. And after we submit the request to Axiomatics PDP, we will analyze the XACML response back to determine what the authorization decision is. Right? So essentially, we completely take out the decision for authorizing the request out of the layer 7 and onto the Axiomatics using the policies that we have developed. And another point here that we'll also look at is that the layer 7 is only capable of supplying a portion of required policy attributes. Because when you look at the XML payload, it's going to have attributes such as physician ID and the patient ID, but it doesn't have any data that determines what is the relationship between that patient and that physician, right? It doesn't tell us anything that that physician was the author of that particular object that we're trying to update, right? So those attributes are still required for the policy evaluation, but they're actually going to be retrieved by the Axiomatics policy server itself through the attribute connectors, and we'll look at that configuration as well. So with that, I'm gonna go into the demo mode here. And what we're going to do is going to log into the layer 7 gateway first. And click through some annoying Java warnings.
Security is important.
Okay. Okay, so here we have our layer 7 policy manager interface. And what we did for this demo, we really essentially exposed a built-in API. We call it HL7 API. I don't know how many people are familiar with layer 7, but the way you kind of build the policy is by building a series of assertions, what they call assertions, which essentially creates a workflow, like a pipeline of API request processing. It kind of steps through the different assertions sequentially, and there's certain logic we can insert there, some validations as well. So we define the HL7 API, right? So essentially, anything that's going to come to the layer 7 gateway under /HL7 will be considered part of our API call. So we are going to be processing the API call. So layer 7 is going to do some request, processing just to make sure that we're using the correct HTTP method, which is a post, that our URL is correct. It's /HL7. We can validate the XML schema, right, just to make sure that our XML payload is in the correct format. We can also do a lot of different API threat management processing here as well, like check for SQL attacks or code injections and whatnot. And once all of that is passed and the call is deemed to be correct, we coming to the actual authorization decision. Right? So we need to be able to look at that XML payload and determine whether that request is actually authorized or not. And we're going to do that through a call out to the Axiomatics PDP. And so let me open that up. So here we have basically a snippet or a reusable fragment, as layer 7 calls it. So essentially, that fragment is going to look at the request, look at the payload, and build the attributes that are necessary to build the XACML assertion, and then send that assertion over to the Axiomatics PDP, get the response, and then process the response to determine whether the request is authorized or not. And we can quickly step through the some of the steps that are required here. So, for example, we can create a little mapping table here that maps the actual URLs of the REST services to the object types and actions that are going to be required by Axiomatics policy. Right. So in this case, we have update progress node REST call, which will create the object type of progress node and action update. Right, and similarly, the create progress node REST call will create the object type of progress node and action create. And that's important because those are going to be the actions, and the object type is going to be passed over in the XACML request. Again, because remember, the XACML policy is not specific to an API, right? It deals with objects, it deals with resources and actions. So it doesn't really know anything about the URL. So the job of the API gateway here is to really map the different REST URLs onto the correct objects and actions.
And that, Alex, if I can jump in, is a very good point, because you want to try to write your authorization policy, your XACML policy, in business terms, not in technical terms. So using the REST URL or using technical artifacts that come from a REST API or SOAP web service or another layer in the NDDEP architecture would actually contaminate the policy. But if you can manage to do the mapping as you just showed now, then you end up with a proper XACML policy that has a translation into business terms, which means that the XACML policy will be only in terms of business objects that make sense to your auditors, that make sense to your compliance managers, and consequently will be easier to report on those policies and get a much clearer view of what is allowed, what is not allowed. Back to you, Alex.
Right. Right there, yeah, and it really improves the reuse, because in this case, let's say we use a REST API, but let's say I have a number of clients that require me to expose my API as a SOAP web service, right? So I can reuse exactly the same XACML policy. I can create and expose a new web service that's using SOAP. All I have to do is just map the SOAP calls into the XACML request correctly, and I can use exactly the same policy to perform the request authorization. So once we determine what the object and the action is, or rather created the mapping, we essentially use some of the layer 7 constructs using XPath to essentially take that object type and take the action and put them into the variables, into the workflow variables. Here's some interesting things that you can also do as part of the layer 7 gateway. let's say you want to add certain location capabilities to your, let's say your authorization, right? So maybe only users coming from the United States can access, patients' data that reside in the United States, but not in the European Union, right? And so we can add that authorization to our policy, but it would say it's going to be the job of the API gateway to determine where the client is coming from. Maybe they use it. Maybe they're going to use an IP address range for that, or maybe they can use a third-party location service, right, to determine where the request is coming from. Enrich that information as part of that API call processing and add it as part of the the authorization request. So okay, so we have our object, we have our country, we have the action. Now, for us to be able to evaluate the policy, we're still missing two attributes that we need to pass, and that is the physician ID and the patient ID. So again, we can use the XPath expressions in layer 7 to essentially get those attribute values out of the XML payload and put them into the variables. So here we're taking the patient ID, putting it into the variable, and likewise for the physician ID as well. So that's coming from the actual payload of the REST call. And now that we have all the attributes that we need, we can actually build the XACML request. Make this a little bigger. So in this case, the XACML request is packaged inside the SOAP message, inside the SOAP body. As you can see, all we have to do is just substitute certain values in that request for our workload variables. Our country code, the requester ID, which is the physician ID, similarly for the patient, and the type of the object and the action that we're performing. Right. So, and once that XACML request is created, we can essentially make a HTTP callout to the PDP. This is the assertion called HTTP routing. So here you can see we're essentially calling the another server, which is the Axiomatics PDP. That server is going to require authentication. So we actually submitting credentials as HTTP basic credentials, username and password. And then as part of the request, we're basically saying build the request and put that XACML request variable as the essentially the body of that request, right? And we can also add additional headers to the request, like for example, we can add SOAP action, and then the actual XACML SOAP request is going to be put as part of the request body. Once the request is sent over and the response is received, we can save that response, which is also going to be a SOAP message, as part of the variable called XACML response. And the next step, once we got the response, is really going to be to try to get the decision out of that response. So we can use an XPath again to get to the XACML decision element and store it in a variable called XACML decision. And that could be either permit or deny. And then essentially we just have to evaluate that decision, right? So if the decision, equals to permit, then we're good to go. Otherwise, we're going to stop processing this request, right? And essentially, layer 7 gateway at that point is going to send an error message back to the client, and the content of that error message can be customized by default. It's just basically a stack trace of the policy, so we can use this in the development and debugging, but you can also customize what that response is going to look like to the actual customer, the actual client. But obviously, the point here is that if we get anything other than permit from Axiomatics PDP, we are essentially going to stop processing that request. Okay, and so now think I'm going to do a quick time check, so it's about 10:46. I'm going to do a very quick demo just to show you how that request would work. And I have a little SOAP UI project here with a couple of test cases. So for example, we have a test case here for Dr. Bob. This is our use case. So Dr. Bob is going to try to create a progress node. Give it ID 12. So Dr. Bob's physician ID is A101, and Sam Jones' patient ID is 1001. So we know that Dr. Bob is the primary physician for Sam. So this request technically should execute if everything is configured properly. And let's run that. Okay, so we got a response 201 created, so that's an indication of a successful result. And if we go to our database backend, we should see a progress node with ID of 12 being created for these. There it is. So this is our request that we just submitted. Likewise, if we let's say try to run the alternative scenario and say now Dr. Dan is trying to create the request for Sam, right? So Dan's ID is A103, and Sam's patient ID is 1001. And we're going to try to create a new progress node by a physician who is not a primary physician for this patient. It should technically fail. There we are. So we got back a stack trace from layer 7, basically telling us that the request failed because the policy was falsified. And if we scroll down, we should see a stack trace of the XACML request and response. So this is the request we're sending in. This is our XACML response, and the decision was denied because obviously, Dr. Dan is not the primary physician for Sam. So again, as you can see that the policy evaluation was done by Axiomatics Policy Server and called out from layer 7. So layer 7 really didn't have any authorization logic built into that policy. And let's see. I have about 10 minutes, so I think I'm just going to go back to the slides because we have a couple more slides to cover. We have about 10 minutes left. So that was. Oops.
That was a pretty neat live demo, by the way, Alex. It really shows the power of the combination of the Layer 7 gateway with the Axiomatics Policy Server.
Right. And so one more thing I wanted to mention, we don't have a whole lot of time to talk about that, but I want to talk a little bit about the authorization on the application layer. So far we've mainly been talking about enforcing the authorization logic on the API gateway on the Layer 7. But we can also do authorization checks on the app layer as well, right? Because obviously once the Layer 7 processes and authorizes the request, it's going to pass that request over to the backend application server, right? And the application server itself can also do additional authorization checks, right? It can potentially enforce the same set of policies. Maybe in some organizations you may have an external API that go through an API gateway, and then internal APIs that are potentially not protected by the gateway, so you can actually enforce same set of policies on the application layer as you do on the API gateway, or it could be a different subset of policies because as the request goes through the API gateway to the application server, it might potentially be enriched with additional attributes, and you can actually make a more fine-grained authorization decision down on the application server layer. And so for Java applications, as what we have with this particular projects, we found a good fit to actually use a Spring Security Framework, where we can implement an XACML PAP, PEP, using a custom permission evaluator implementation. And what it really does, it allows us to completely decouple the authorization from the application logic, right? You can reuse those classes across different applications. You can kind of ensure consistent enforcement of those policies across multiple apps. And it really allows for declarative security. You can now essentially use annotations when you write the Java code. You can just put an annotation in the method definition, as you can see here on the screen, the pre-authorized clause, and pass information about the request and maybe some value object with attributes about that request into the permission evaluated class, which will then essentially build the XACML request, send it to the Axiomatics Policy Server, receive the response, and then make a decision whether that method call should be authorized or not. And do you have any more insight or comments on the Spring Security?
No, other than it is a possibility, of course. It is possible now that you externalize authorization, as you explained, to actually insert the checks and insert the enforcement where they matter most. Sometimes it's the API level, partly because you've already defined the contracts, you've already defined your WSDL in the case of SOAP, or your REST endpoints. Sometimes you actually need to go down to the method level, potentially because you have a business process that you're implementing within code. So a combination of both approaches is a very good approach usually, and you have to find yourself the balance between which types of enforcement you want to have. And ultimately, if both the API layer and the business logic layer are not enough, you can still go down to the data layer.
Right. Okay, so with that, I'm going to go to the summary. So I think what we want to reinforce what we talked about today is that we can really effectively use the ABAC, XACML, and Axiomatics to build the API security frameworks. We can integrate Axiomatics Policy Server with a variety of different platforms, including API gateways such as Layer 7. The main benefits, really, we can decouple the authorization logic from API implementation, whether it's API gateway or your own applications, and really provide a consistent enforcement across multiple APIs and multiple layers of the application architecture. And with that, we're going to open it up for questions.
Thanks, Alex. So we have a couple of questions that came in. One specific question on the use case, Alex, that came in earlier on was, is primary physician a role within the institution, or is it related to the patient? So in other words, is it an attribute of the user or an attribute of the resource? And also, how do you authenticate the patient? How do you identify the patient? How do you identify the requesting entity? Do you want to shed some light on that, Alex?
So on the first question, in this particular use case, it was an attribute of the patient, right? So the patient was assigned a primary physician, so that would be an attribute of the patient. And when the Axiomatics Policy Server resolves that attribute, it will actually look at the patient record based on the patient ID in the request to determine who the primary physician of the patient is, and then compare that ID of the primary physician to the ID of the physician ID that is supplied in the request, and that's how it makes that connection to determine whether that particular physician is authorized to access that patient record or not. What was the second question again, Dave?
How do you identify both the requesting entity and the patient?
Well, the actual authentication of requests, I guess, was kind of out of scope for this this webinar, but there's a number of ways to deal with it, obviously. So if we have a REST API, we can use OAuth for request authentication that authenticates the actual client, the entity that submits the request. This particular project that we were working on, there was actually also a web front end in front of that API that used SiteMinder for authentication of the staff member. And then it was actually passing SiteMinder session along with the request, and that was used to authenticate that request. So it really depends on the implementation. There's a number of ways to authenticate requests with the API calls.
Right, and what I might add, Alex, to this. Sorry, go ahead.
Oh, no, I was going to say, yeah, it could be SAML, OAuth, or any sort of proprietary framework.
Right. And what's interesting as well is that within the authorization policies, you can check what type of authentication was used, whether SAML, OAuth, two-factor, strong authentication, so on and so forth, and actually make decisions based on that. So it might be that you are allowed to view a patient record if you've used username, password, but in order to edit a record, you need a PIV-ID card to augment your authentication and have stronger authentication, essentially.
Right. So that would be one of the environment attributes, correct?
Correct. Yeah, it would be an environment attribute. Now, another question, Alex, that came in is, in the demo that you did, you apply authorization on the way in at the API level. Is it possible to do authorization on the way out as well?
Absolutely. In fact, one thing for simplicity, we omitted that part out of the demo, but you can, when the layer 7, let's take layer 7 as an example, after it submits request to the backend application server, it receives the response. That response can be put through a workflow, right? So we can analyze the response and we can look at is the data in the right format. We can make another authorization check to enforce maybe data like a DLP policy or whatever, that we actually not sending out some critical or data that is not authorized as part of that particular request for that user. Absolutely, we can enforce that on the way in or on the way out.
And another question, Alex, I don't know if you did any measurements in this particular setup for the customer. Do you have any performance metrics, and do you know what the impact is on using externalized authorization at the API level?
Well, we don't have any performance metrics for this particular project. So, I mean, obviously, there is going to be an impact, and there are ways to deal with that. And I think, David, you can probably even speak to that as well, because you support a number of different protocols. Obviously, if you're using SOAP and HTTP, that may introduce some latency delays. I know that Axiomatics supports other protocols, some binary protocols that may, you know, improve performance a little bit, but I don't have any specific performance data.
Right. So what I can go ahead and add to that, Alex, is that on the one hand, you can definitely choose the protocol between the PEP, in this case, the layer 7 gateway, and the policy decision point within the Axiomatics Policy Server. So by default, it's SOAP, but we also support the JSON profile. It could also be a binary protocol such as Apache Thrift. But another interesting option that you have specifically with layer 7 and Axiomatics is that you can actually embed the Axiomatics policy decision point within the layer 7 gateway. And if you do that, of course, you actually avoid the network latency because it's just an in-process call.
Right. Yeah, and that is always an option, right? So sort of a co-location of the decision point with the, you know, the gateway or the application server is always an option if performance is a, you know, critical concern.
Right. And on that note, Alex, it's the top of the hour, so I'd like to thank you for joining us today, and thank everyone for attending the webinar. And as a reminder, these slides will be available on the axiomatics.com website, as well as the video recording. Thank you, everyone. Thank you, Alex, and have a nice day.
Thanks, everybody.